class we study that the what is the Newton's law of motions formulas, their denotations. That will be the uh, here is the u equal to u, sorry, v equal to u plus at. This is the velocity time relation. After that, s equal to ut plus half at square. This is the displacement time relations. And the next is the u square equal to v square plus us. This is the displacement velocity relation. So now you can how to this formula comes. First one, so in this class we will study just wait, how this formula comes or how this formula derives. So in this class we study about that how this formula will become. So yes, just wait. So equation describe the relation between the velocity and time. So you already know that you can do find out the formula for velocity and time. Okay, so that will become what will the formula, v equal to u plus at. Okay, this is the velocity time formula for the calculation problem. So if you the given the velocity, you can calculate it according to that final velocity. If you are given the final velocity, you can calculate initial velocity u plus at. According to that initial velocity time graph will be help to you. So in this figures you see that the change in velocity with the time of uniform acceleration object. So yeah, the object starts from point D. So object starts from the point D. Here is the point D from starting here. Just wait, I will little graph size. Yes, okay, fine. So just wait, I will also brush size increases. Yeah, okay, fine. So start from point D. Object starts from time D and graph with velocity u. Here is the velocity u. So from this to this velocity is u. Its velocity keeps increasing after time t. So here the time passes, velocity will be increases like this. Okay, increases and reaches point b. After the reaches a point of the b velocity. Okay, the initial velocity of object u. Okay, so initial velocity is the, here is the v. Okay, initial velocity is the u, means starting point is the, and what will be there denoted by od. Is it correct? This is the o point and origin, and this is the d point. Okay, next is the final velocity of object is the oc. Where is the final velocity is there? So this is the final velocity is there. So you can draw this line so equivalent to this. So that will be velocity, final velocity is the what will be OC. Is correct? So time is a t. Where is the time passes? Here is the time passes to this one. So what will be time passes? Here the time passes with the t. Okay, so here is a OE. Okay, just wait now. So understood that what will be the initial velocity, final velocity, and the time passes. So according to put this equation, so we will be find the so acceleration equal to change in velocity upon time. So what will be change in velocity here? So means initial velocity what will be there, and final velocity, that will be change in velocity. So here the acceleration equal to change in velocity upon time. So change in initial velocity minus uh, final velocity minus initial velocity upon time is the you can calculate the change in velocity. So here is the OC what will be there? Here is the OC, this one. Okay, this will the final velocity, is it, minus OD, this will the initial velocity upon time t, this one. Okay, so just wait. So change in velocity upon time is there. So initial velocity is this one, final velocity is this one. So initial velocity is the OD and final velocity is the OC. So you can minus from final to initial, you can got a change in velocity. So how to minus? Suppose this one is the total is a 10. Suppose the total is a 10, and you can minus here is from 4, is it? So 10 minus 4 equal to 6, is it? So what will be 6? This one is a 6, is it correct? So yes, correct. So according to that, here is also OC minus OD, is it? OC is the, this full is OC, and minus from this, so you find this one is a this one is the remaining, is it? So that will be the CD, is it? So that will be the CD equal to OC minus this one. So again you can draw the graph for better understanding or comparison your our formula. What is our formula for final derivation? Is that u equal to phi equal to u plus at. You want to do that final equation. So just draw a parallel line, to y axis passing through the B. So passing this one with the y axis, just wait, this one is the y axis, parallel to this you can draw the this line, is it? uh, Passing at the point B. Okay, this will be crosses the x at a point E. It crosses at point E here, is it? Yes, E. Draw a line parallel to the y-axis and passing through D. So parallel to the y-axis means this parallel to the y-axis, this one. So passing to point is a D, is it? So this one will be parallel to D. This will crosses a BE. This will crosses a BE at a point A. Okay, so that will be changes from your graph. Okay, so understood that where is the changes go according? So according to, just wait, so now from graph this one graph, from graph BE, where is the BE? This one is the BE, is it? This one is the BE. BE equal to what? This one plus this one, is it? Yes. So from graph BE equal to AB, this one AB plus AE, is it? Okay. Similarly, what will be there given that with respect to this BE? B is the velocity equal to CD plus OD. So this one CD plus OD. You can also consider that CD plus OD, is it? Yes. So AB equal to CD and yes, what is AB equal to this one? Yes, is it? Oh, just wait, you are not seeing that. AB equal to CD and OE equal to AE equal to OD, is it? Just so this one equal to this also means OE equal to OD. So from this equation you can put the value CD, you know about that, CD equal to 80 is yours. So how to 80 come is there, this A come to this side, so that will become to 80, means you can acceleration into this one, so A come from this side to this side, so you got a 80, this one. Okay, so here is a CD equal to 80, V equal to 80 plus U. After from equation this, so rearrange this equation, you can got a final equation V equal to U plus 80, is it? So this will be the final equation for you for first law. Okay, so revise that the graphical relationship for velocity and time. So here is the velocity is in this point is not a zero, it has some velocity. So initial velocity is a D point is here and final velocity is the B point here. So initial minus, yes, so initial here is a D and here is the final is the B. So final minus initial is the change in velocity. Here you can find that. Okay, and you know that the uniform velocity graph is the straight line. So here the graph is also straight line, is it? So in this time the time is here and in there is the velocity is there. So time and velocity graph will be straight line in uniform motion. So is it? So here is that. So you need to the equation for that, so that is the final equation for this is the first equation for the motion. So that is the equation, first equation for the motion, and this is called the first law of motion also. So this is the v equal to u plus at is the final equation. That is a very important to use. Okay, so that will be remember, and there will be asked for problem related to that. If you given the initial velocity or final velocity, you can calculate the any one of that according to given theirs. Okay, yes.